In this fifth exam question we're going to look at, I'm just looking at one that's a little bit more in context. And what we've got here is a particle of mass 4 kilograms held in equilibrium, again that's that word equilibrium, by two light and extensible strings. So now we're adding a bit more information here, like light and inextensible. Now we've come across light and extensible strings before in other areas in Unit 2 and Unit 4, and that just means that if they're not elastic, because if they were elastic the tension would vary and we wouldn't be able to apply the component forces that we would normally want to do in these types of questions. So normally if we have strings in Unit 2 and 4, they are light and extensible. Light also means as well they carry no weight, so they don't have any effect on the system. So in this case, they're in equilibrium and we're wanting to find out the angle alpha that AP makes with the horizontal. We also know that the tension in the string BP is 30 newtons. So the first thing to do is probably label a bit more information on this diagram. So in the first instance, if the mass of the object, the particle, is 4 kilograms, we're going to have 4g newtons acting downwards. We're also going to have the 30 newtons that's in PB, so it's 30 newtons tension there. But also we have this tension AP, so I'm going to call that T because we don't know what that is either. So again, we can see that we have two unknowns, but we are able to form two equations by resolving the horizontal and vertical. So again, I'm going to make sure that I get my right angle triangle to get my horizontal components, which are going to be here with the force T newtons and alpha. And again, if I set up my components, we're going to have T sine alpha in the vertical and T cos alpha in the horizontal. If I now go to look at each component in the horizontal in turn and vertical, if I look at my horizontal, I have 30, take away T cos alpha, which is equal to 0, because remember, it's in equilibrium. So in other words, I might write this already as T cos alpha is equal to 30. If I now look in my vertical, I have T sine alpha, take away 4g is also equal to 0. So I'm going to write that as T sine alpha is equal to 4g. Now with these two equations here, I could do a rearrangement, I could do substitution, but again, I noticed something about my trig identities here. If I write both these equations on top of each other, T sine alpha is equal to 4g and T cos alpha is equal to 30. If I divide both of these equations, I can see that the t's would cancel, and sine alpha over cos alpha, you should know, is tan alpha. So I'm left with tan alpha is 4g over 30. That means alpha is going to be the inverse tan of 4g over 30, which gives me an answer for alpha as being 52.57 degrees. Finally, now I know what alpha is, I can use one of my equations. So I'll use my vertical equation here. I know that T sine alpha was 4g. I now know that alpha is 52.57. So T sine 52.57 is 4g. T is 4g divided by sine 52.57, giving a T value of 49.36 newtons.